Hey everyone, today I want to give you a free preview of my EmSAT Math Mastery videos. You can find the link in the description to the videos, which are on a huge discount. They're just like the YouTube videos that so many of you love, except they're more organized, more detailed, and they also come with formula sheets and 100 pages of EmSAT notes that I made myself just for you. They're absolutely free. At the very least, make sure you grab the free study plan for the EmSAT Math. The link is also there in the description. Okay, so in this video, we'll preview the geometry series and we'll learn how to find the area of a sector of a circle. Let's go. This question says, a circle has a radius of 9 meters. A sector of the circle has a central angle of 7 pi over 6 radians. Find the area of the sector. So a sector just means a slice of a circle. So let's draw a little circle here so we can imagine what we're talking about. Here's a circle, and when they're saying 7 pi over 6, I'll just do this quickly on the side. They didn't ask us, but I'm just going to show you for practice sake. To convert this into degrees, for example, since radians are on top, I'll put them on bottom because that's what I want to change, and I want to change it to degrees. Now I know the relationship is that 180 degrees is pi radians. Radians will cancel out. What am I going to have? 7 pi times 180 over 6 times pi, so 6 pi. And the only unit left is degrees. I can cancel out the pi with the pi. This 6 and 180 will simplify to 1 and 30. So I get 7 times 30, which is 210 degrees. So that means we always measure the degrees from this positive x, if you will, over here. So when they say 210, I know this is 0, this is 90, that's 180, so I need to go about 30 below that. So how about we call this one here, we'll call that one the 7 pi over 6 rad angle, or 210, whatever you prefer. Now they want us to calculate the area of that sector, this large sector over here. So I'll give you the formula to calculate the area of a sector, both in radians and degrees. So if using radians, it's actually easier. You get the area of a sector is 1/2 times the radius squared times the angle in radians. Since they gave it to us in radians, I recommend we use this one. And if you're using degrees, the area of the sector works a little bit like this. Pi r squared, as we know, is a full circle, but we don't have a full circle. We don't have a full circle. What do we have? We have some portion of the circle. What proportion of the circle do we have? What fraction of the circle do we have? We have this angle, whatever it is. In this case, it's 210 degrees, but let's imagine it's anything. It can be anything. We have this many degrees out of a full circle. So if you were to find the angle in degrees and they ask you to find the area of a sector, you can use this formula, which is basically a full circle multiplied by the portion of the circle that you have. If you only have 30 degrees, that means you have 30 out of 360 degrees. You only have a 1/12 of the full circle. If you had 90, that would mean you have 90 over 360. That's 1/4. That means you only have 1/4 of the full circle, and so on. So this works for absolutely any angle you have when you have it in degrees. So let's continue now. They asked us to find the area, and we already have the angle in radians, so we can just plug it in here. We also know that the radius is 9 centimeters. And so you just put it in here. You say 1/2 times 9 squared times 7 pi over 6. And when you put that in your calculator, you will get 148.44 centimeters squared, because it's an area. And this rounds off to the nearest tenth to 148.4. Because this 4 is not strong enough to push that tenth into the 5. So there you go. That's our final answer. Okay, I hope that was helpful. Now make sure to click the link, check out the videos. Like I said, the EmSAT Math Mastery video series on a huge discount. Comes with a bunch of notes, very organized, very detailed. Make sure you check it out now. At the very least, make sure you grab that free study plan, and I'll see you there. Take care.